Okay, now we're continuing. So our next one is number 11, and what it's asking about is the intercepts, the domain and range. It basically asks everything at once right here, but then it repeats it here. So here's the A part. It wants to know what the intercepts are, and on these, the intercepts are the x-intercepts and the y-intercepts. So it wants the ordered pair, so you use a comma. And so let me just mark it over here first. So -1, 0 and 2, 0 are your x-intercepts. Don't forget about your y-intercept, which is at 0, 1. So the order shouldn't matter, but you do need a comma between them. So we've got -1, 0, 2, 0, and 0, 1. Again, make sure you have parentheses. Use parentheses, not brackets. Okay, then the domain. So notice there is definite starting and stopping points. The domain would go from -3 to 3. So if I think of this as your domain from -3 to 3, you could say -3 less than or equal to x less than or equal to 3. But since it wants an interval notation, then you've got to just do bracket -3, 3. So that's the answer for this one. So that one uses brackets. So the range would be from here to here. And so that's basically 0 less than or equal to y less than or equal to 1. But what you're going to put is 0, 1 in brackets. Okay, so that's parts A and B. The next part is, where is it increasing? Well, it is from -1 to 0. And it wants a comma, and then 2 to 3. So again, on this one, use parentheses. Whoops, I put an extra T. Oh well, I teach math, not English. Okay. That's fine. I'm just going to say use parentheses. Okay. Okay. So that is A, but it's those two. And then it's decreasing from -3 to -1. And it's also decreasing from 0 to 2. Now, just to reinforce, I think I said this before, maybe I didn't, but increasing and decreasing use x values, not y values. They use x values, not y values. And this one's not flat at all, so it's not. And it's not symmetric to the origin or the y-axis, so it's neither. So that's neither odd nor even. Okay, so that's one of the longer questions as far as having a lot of parts. The next one there's no x-intercept, but the y-intercept is 0, 5. Okay, now these have arrows, and so again with interval notation we're going to want negative infinity to infinity. So it's basically real numbers, but you put this since it has arrows. So you see those. The next part, the range. Now we had something like this last year. You might have seen it in Algebra 2. It looks like if you count 1, 2, 3, 4, 4 is where your horizontal asymptote is. Horizontal asymptote at y equal 4, which means your range would be not including 4 and then going to infinity. So your range is from low to high, and this one's a parentheses, and this one is because it involves infinity. So you want 4 infinity. So the next one's talking about increasing. It's increasing the whole way through, so there's no interval that it's decreasing, which is over here. It's increasing throughout the whole thing, so you'd say increasing from negative infinity to infinity. And it's not constant at all, and it's neither. So again, it's using our definitions with increasing and decreasing and constant. Okay, now this is a trig function. We talked about those a little bit in Algebra 2. And this one in particular is the sine function. It's abbreviated SIN, but it's wavy and goes through the origin. Through the origin. And the intercepts would be at negative pi. So negative pi, 0, comma. It's also at 0, 0. And it's also at pi 0. In this case, your x and y intercept of 0, 0 is the same. So don't have 4 answers for this. 3 is adequate. Now, since it doesn't have arrows, it's going from negative pi to pi, like this. And your range is from the negative 3 to the positive 3. Now the reason is because it actually touches those numbers. There's not an open circle right there. It actually touches that point. And then it's increasing this part, and then it's decreasing here and here. So it's increasing from negative pi halves to pi halves. Remember, just use your x's. And then it's decreasing from negative pi to negative pi halves. And it's also from pi halves to pi. Here's where these are. I know you may not have been able to see that, but Domain was negative pi to pi, range negative 3 to 3. And then it's increasing from negative pi halves to pi halves, which is the middle, basically. And then this is the left side, and this is the right side. So okay, and since it's wavy, it's not constant at all. And this is an example of one that is odd because it's symmetric to the origin, because this part matches to that part. So this is odd. Okay, so there's that one. The next one, my first intercept is there at 0, 0, which is both an x-intercept and a y-intercept. Now, the other one is right there, and on paper, looks like you have to estimate it to be a half, estimate to 0.5. So this would be like 2.5, and it's going to want 5 halves. So that's going to be 5 halves, comma 0. On MathXL, it may show up a little more clear. If it doesn't show you the function name, like y equal whatever, then you can't be too exact. So that's why we have to estimate. Okay, the domain is going to be from negative 3 to 3. And your range is from negative 1 to 2. So low to high, this is left to right. Okay, it's increasing kind of like from 2 to 3. And remember, when we're doing increasing and decreasing, we use parentheses. And then it's decreasing from negative 1 to 1. And it's constant. This is your first one that's constant. It's from negative 3 to negative 1. And it's also constant from 1 to 2. So this one looks like part of a constellation for those interested in science or whatever. But that has all 3 aspects. And it would have to be neither, even or odd. Okay, the next one, find the number that has a local maximum, and okay, the local maximum is where it's the highest. Okay, so here's the tricky one about this. This is a continuous graph, and it doesn't stop right there, but for the local, it's going to want this one, which is x equals 0, and then y equal 1. So this is your local maximum. It's not the edges, okay? Because it continues. It doesn't have a little dot there. So then the next one, for B, you have minimums at this spot and this spot. And so that's -2, 2. Don't use parentheses, we're just talking about x's. So right there at -2 and 2. And then the y value is at 0 for both of them. So I'm going to put 0, 0. So you could on Math Excel try 0 once. See if it works. But on paper, the key would have both. Okay, so it's really important that you put x answers for this and y answers for this. Okay, our next one is another sine function, and it wants the local maximum. So the x answer for the max is pi halves, and the y answer is 9. So think of this as the x, this is the y, and again x and then y. This is for minimum, so this would be negative pi halves and -9. Okay, so those look longer, but it's actually quick once you get the hang of it. Okay, so this one says determine algebraically whether it's even, odd, or neither. Okay, so let's give you the quick way first. So graphing, we go to a new document, add graph, -2x up arrow 3, enter. It's like that. It exactly goes through the origin, which means it's going to be odd. So you kind of know that right off the bat. What we said is if it's an odd exponent, it might be odd. Odd exponent means might be odd. Now let's do the algebraic part. So what we would need to do is use f of, well, I'm first going to just write my problem. So now you want to do f of -x. So when you do f of -x, then we say -2 parentheses -x to the third power. On this one, I'm going to write more steps than you probably will, just to make it very, very clear what we're doing. So if it's -x to the third, that's like -x squared and then another -x. So what that looks like is that it's -2x squared and a -x, which is really positive 2x cubed. Now how -2x cubed relates is it's not equal to 2x cubed, and its opposite sign, so it's odd. I know that's going to be a lot more writing than you do, but if you're doing like -x to the fifth, it's going to be the same way, where it's odd. But if you do something like -x to the fourth, it could be even. So check each problem to be sure, but I think if it's an odd exponent with a negative, it would work once you work it out. So I basically broke down the cubic into a squared and a regular. The negative squared is a positive because it's inside parentheses, and then the negative of a negative is a positive. And then you have x cubed. So that's the algebraic way. This one, again, if you were to graph this, even just in general, it's going down 4. That's going to be like that, which is even. But the algebra would be like f of x equals 6x squared minus 4. So then f of negative x would be 6 times negative x squared minus 4, which is 6x squared minus 4. Those are the same, and so it's even. So that's how that works. Okay. Now this one's a bit weird. So remember, that would be the same thing as saying 5x to the 1/9. That still looks pretty weird. The graph would go up very, very slowly. Let's graph it. Pressing escape, then tab. Okay, fine. It wanted me to pick a graph first. Okay, so this one we do the control up arrow because that's the end of the x, and then we want the 9th root of 5x. Okay, that looks like that. And so really quickly from the graph you can see it's odd. Now if we do our thing like before, f of negative x would be the 9th root of 5 times negative x. So that'd be the 9th root of negative 5x, and then that is equal to negative 9th root 5x. And that's the opposite sign of that one. So basically you're able to pull out your negative sign because there's no other stuff over here. And those don't match, they're opposite signs, and so it's odd. Okay, number 20. Graph of this one, negative 5x squared plus, okay, now we're doing the absolute value symbols, so that's to the right of the 9, and it's right there on the right side. So this function is not just quadratic, it's not just absolute, it's both. So it's a combination of functions, which is kind of like what they do in calculus also, showing you different types. But this is an example that's symmetric to the y-axis, and so that'd be even. Graph basically looked like that and then that. So that's even. because it's symmetric to the y-axis. So if we did our thing like before, -5 negative x squared plus absolute value 3 times negative x. Okay, so this part, if it's negative x squared, that'd be positive x squared, because a negative times a negative is a positive. And if you're doing the absolute value of negative 3x, that's the same thing as the absolute value of the positive 3x. It just works out that way. And so they are indeed matching, they're the same. Okay, the next one, this is a rational function, or somewhere they call it reciprocal. On this one, make sure you do your parentheses. So what I'm making sure is you do this. Okay, so this one, when I look at it, it's not symmetric diagonally, but it is to the y-axis, and so this would be even. So what's happening in general is it's going like that, and then it's going like that, and that. It's not to scale, but that's basically what it's doing. Again, anytime we do x squared, it's just going to work out so that's x squared plus 4 over x squared minus 2, and that matches, and so it's even. Here's this, which I just wrote. So your graph looked like this, where the left and right kind of matched, and here too. It's not to scale. And here's where I put F instead of G. It doesn't really matter in this case. But if you do your negative x's in there, they change to positives. So, yeah. Okay, 22. Okay, so this one has odd exponents, so I would think it's either going to be odd or it's going to be neither. On this one, make sure you do 3x cubed divided by parentheses, 6x squared minus 1. It's very important that you use parentheses. Okay, so this is pretty weird, but it does look like it matches in both diagonal quadrants. I'll try that on for size. It's going like this, and then coming down, and then it's doing this number, and then it's doing this number, and then up. So that's odd because it's symmetric to the origin. Now, I'm not going to get into it on this lesson, but what I could do, but I'm not going to, is tell you, well, your exponent's bigger in your numerator than your denominator, and so it's going to have a slant asymptote, but we'll figure that out later. That'll be another lesson, and it doesn't ask for it at this time. You'd have to use your synthetic division or long division. to actually get it. Okay, back to this one, 23. So now we want the, well, first let me just mention, this would be a local minimum. Notice there are dots. This would be the absolute minimum. In the same way, this is your local max and your absolute max. So the absolute max is 6 because it wants the y value from the ordered pair 2, 6. And this one, it's 1 because it's the y value from 7, 1. So that's what you want for that. The locals are in the middle, and the absolutes are here, just because it's the highest up. They could have had the graph oriented different, so it's not really about if it's left or right. It's that the absolute is tallest. And that's for the absolute max. And the absolute minimum is the shortest. Okay, this one, it's a combination of functions, and you want the absolute max. So that's this one. And so that's 7. And the minimum would be this one, which is 3. Okay. On 25, so this one, it's a little bit different. It has an arrow. So no absolute max. It just keeps on going. There's not a specific value that it stops at. And then this is your absolute min. So it's 1 from 0, 1. 1 is your answer. So these other points aren't needed. Now, it doesn't talk about a specific domain or anything. It's talking about the whole thing, basically. So, yeah. Okay, on this one, okay, now this is a hole in the graph, and so that'd be no absolute minimum. And in the same way, that looks like no absolute maximum due to holes, because of the holes. So none for both of those. So it would have been right there, but you can't say it because it's a circle instead of a dot or a line. Okay, this one. Okay, now on this one you have to use your calculator, and they want you to round to 2 decimal places. First we want to graph it. Okay, there's the graph. Now it really just cares about or wants the information on -2 to 2. And so if you really wanted to, you could do something like this, -2 to 2. I need to pause the video for a second. Okay, so this time we have the x to the 7th. Okay, we're back. Couple of interruptions, no problem. Just make sure. Okay, so I really do have it already. I have x to the 7th minus 3x to the 5th. Now, what I care about is the interval -2 to 2. So I'm going to hit escape to get rid of that. And I put -2 to 2. Okay, so what we want is where it's increasing and decreasing. Remember, increasing doesn't just start at the x-axis. It's starting down here and increasing to whatever number that is. Now, how we get that number is we do menu, analyze, maximum between here and there. So I get my y answer to be 5.76. So 5.76. Oh, and by the way, the graph looks like A because it's lowest down here and then it goes. So, okay, let me pause this again. Okay, full of interruptions. But as we were saying, when you round, you're having 5.761. So based on that 1, you round down, so 5.76. Now, the other minimum looks like it's going to be right over here. Menu, analyze, minimum between here and there. It's -5.76. Oh, hold on. Okay, so that's one of them. Oh, so the first one was 5.76, and that occurred at -1.46. The next one is the -5.76 and occurs at +1.46. Now, to me, if you look at those numbers, they're the same numbers and opposite signs. So it's probably odd. Probably odd. I'm not going to go through a proof of it, but they are both odd exponents, and that is the behavior we see with like this point and this point. You know, they do correspond symmetric to the origin. So I'm going to say yeah. Okay, where is it increasing? So it's increasing from the start, which you can't say negative infinity because it starts at -2. So from -2 to -1.46. So that's one of them. And then from +1.46 to 2. And so that's that first one. And then it's decreasing here to here. Don't overthink it and say that it stops decreasing here, because it really goes down further and further. So from there to there, like that. So from -1.46 to 1.46. I guess technically, if you want to zoom in, and if you wanted to trace, you could see it's getting smaller and smaller. I just keep it simple, and that's what it is. Okay, next one, same idea. This time we're going from -6 to 4. I'm clearing mine now since we messed with the window. -0.3x to the 3rd power minus 0.7x to the second power plus 3x minus 4. Lots of movements on this. Okay, so you may want to do zoom fit. Menu for A is zoom fit. So it looks like that. Which is this one. Wait. Let's look at the interval from -6 to 4 for a better look. Really? Okay. Okay, and this you want from -25 to 10. And as we change these, it's going to look more like one of the choices. And now you can actually see it's choice B. So use your window. So that's what we had to do. Okay, now we want the local maximum, which would be this spot. So from here to here, -1.9. Okay, it says 2.6, so we got to round to 3. So -1.93. And the x value is 1.206, so we have to round that to 1. So 1.21. And that's for the max. For the minimum, that's down here. So from here to here, -11.30. And -2.762, so we round down, so -2.76. And then it's increasing between here and here, which was your -2.76 to -1.93. Oh, sorry, from x value to x value. So from -2.76 to 1.21. Now, here's something I remember from years ago. These numbers have to be one of those. The numbers should look familiar. So, like, these numbers, if you have an issue with rounding, like, what if I got 4 there? Well, it's supposed to be 3. You know what I'm saying? So these numbers should look familiar. And the increasing was the in-between part. And the decreasing is going to be from the -6 to -2.76, which is this end. And it's also decreasing from 1.21 to the end, which is 4. So that's this one. So that's it. So this was your left window boundary. And then the 4 was the right window boundary. Okay. Okay, moving on. Now the average rate of change. So when we think of rate of change, we think change in y over change in x. We're going from 1 to 3, and so what that means is you can even rewrite it as change in delta x. So what does that mean? it means f of 3 minus f of 1 over 3 minus 1, which is 2. And then you can put 3 in here and say 3 squared plus 1 is 10. And f of 1 would be 1 squared plus 1, which is 2. So you get 8 halves, which is 4. Now, if you don't like doing it that way, you could do this and say x squared plus 1, then go to your table, and f of 3 is 10, and f of 1 was 2. So I don't want to get too far advanced on other stuff, but as far as like plugging it in, just you can do it that way. Now I went from 4 to 6, so I'm going to say f of 6 minus f of 4 over 6 minus 4. So that'd be 37 minus 17 over 2. That's 20 over 2, which is 10. Okay. Now from negative 1 to 2, well, negative 1, okay, so f of 2 minus f of negative 1 over 2 minus negative 1, which is 3. This is like 2 plus 1, so that's why you change it to 3. And f of 2 is 5, and f of negative 1 is 2, so you get 3/3, which is 1. So 4, 10, 1 for that one. The next one, you're doing f of negative 3 minus f of negative 4 over negative 3 minus a negative 4, which is just 1. Let's type in our value, our function. X to the third power minus 6x plus 2. Okay, so there you go. Go to your table. Negative 4 to negative 3. Okay, well, negative 4 is, do negative 3 first. Negative 3 is negative 7, and negative 4 is negative 38. So that's going to actually be like plus 38. Negative 7 plus 38 is 31, which is this answer. And then on this one, it's f of 4 minus f of negative 1 over 4 minus negative 1, which gives you 5 on the denominator. And then f of positive 4 is 42, and f of negative 1 is 7. 42 minus 7 is 35 over 5, which is 7. So the numbers really do work out. And then on this one, f of 8 minus f of 4 over 8 minus 4. F of 8 is 466, and f of 4 is 42. While I'm on this one, because it is a little bit more complicated than that one, just remind you about how to do this on your calculator. Basically, you would need parentheses 466 minus 42, and then divide by 4. You get 106. Okay. And then 31. We are almost done. Looks like 31's our last one. Okay, the average rate of change from 3 to 5 on this function. Okay, if you want the shortest way to get it, and you want the average rate of change on a linear function, it's going to be the slope. And so since this was 4x, it's going to be 4. Now you could probably do it another way, like f of 5 minus f of 3 over 5 minus 3. So you have 2 on bottom. F of 5 would be 20 minus 7 is 13. F of 3 would be 4 times 3, 12 minus 7 is 5. So that's 8 halves, which is 4. So again, it does work out, but the shortcut is if it's linear, that's the slope. So the number in front of x. And then the equation for the secant line going through this. Well, first I think I'm going to go ahead and put this. This was 3, 5, and this was 5, 13. Okay, so what we know is it's going to have a slope of 4. And when you think about it, the only possible line that would have those points that's secant to it is the same thing. It's kind of redundant, but this answer is the same as this answer. Because like if you think of it, 4x minus 7 would look like this. And you know from earlier, like on a secant line, it has to go through 2 points. Well, the secant line of the line is the same thing. Secant line of the original, since it's a line, it's the same. Okay. Now we've finished all of those. Make sure you do your Math Excel. Hope that helps. Have a good day.